All right, folks. Can you hear me all right? Perfect. Well, good morning, everybody. We're going to go ahead and get started. Welcome. My name is Konstantin Rivkin, and I have Jeff Millif, a colleague of mine, and we're going to talk about enterprise connectivity to Office 365. So this is a little bit of an unusual session. Just to set the expectations up front, this session is focused on the enterprise connectivity. So if you're working with large deployments connecting to Office 365 across a broad suite of applications, this is probably the right session for you to be in. We're going to look at strategies, not features. We're not going to announce or present any new features. However, we will try to put these features in the context on how to optimize your enterprise network to have Office 365 experience delivered to users more seamlessly in a more performant manner. We will emphasize trends and some of the principles. Hopefully, in the end of this session, you'll gain some understanding on why we're recommending our enterprise customers to connect to Office 365 in a certain way. And really, this session is designed to keep your Office experience best as far as the networking and connectivity is concerned. Well, Jeff and I are engineers at heart and by job, so in this session, we're not going to try to sell you anything. In fact, most of the people may use the materials in this presentation to avoid buying the stuff that they don't really need, again, in the connectivity concept. And finally, this is one of the few sessions where it has a diagram on every slide. So hopefully, you'll be able to use that in your everyday job after the conference, including this one. So the context for this discussion is the users connecting to Office 365. There are a number of related sessions. I would encourage you to take notes and maybe attend some of them. This session is focused on strategies. There is a session focused on implementation, on planning of networking connectivity to Office 365, as well as there are specialty sessions focusing on optimizing network for specific workloads, such as Skype for Business, Exchange Online, SharePoint Online. So if you're interested in figuring out the optimal connectivity strategy and fine-tuning it for the needs of individual applications, there are sessions for that as well. But we're going to focus on the broad strokes. And the first question that I want us to think about is why connectivity is important. A few years ago, we started looking at large-scale enterprise deployments to Office 365, and we observed that while we run the same Office 365 service for every enterprise, the experience that our customers are getting can be quite different. Customers are citing differences in performance, difference in availability or uptime that their users experience with Office 365, different interoperability challenges. The same very client, the same very scenario may work for one enterprise, may not work as flawlessly for another. Customers may have concerns about the scalability as they project their future Office 365 deployments to tens of thousands or hundreds of thousands of seats. And finally, probably the biggest feedback that we're getting from customers is that in certain scenarios, it may be quite complex and cumbersome to connect to Office 365 and migrate the first mailbox, or be able to run their connectivity infrastructure at the fullest scale. So we started looking at this and tried to explain these differences, and the theme that comes over and over again is that connectivity, the network between the user and the software as a service cloud, such as Office 365, is of prime importance for the user stability, experience, and ultimate happiness with a product. One thing that we noticed is that enterprises are challenged to select the right connectivity framework, the right mindset, the right tools to make their connectivity and networking strategies to Office 365 future-proof. So the key question that we're trying to answer in this dialogue is, what are the key principles that you should be thinking about? What are the cornerstones of your connectivity investments that you can make today that would make your networking experience with Office 365 not only excellent, but also future-proof? Now, we've been told by many enterprises that networking investments take time, that for a large enterprise connecting to software as a service cloud, to Office 365, changing the network doings can take months, if not years. So we thought that it's important to ensure that we have a focused discussion about the strategy, the broad stroke patterns, as well as try to explain why the networking world is changing. And if we look at the history, 10 years ago, most enterprises started with a fairly close, self-contained on-premises deployments, where both the users, the data, and the application lived in one self-contained environment. Then 5 years later, managed solutions happen. And in managed solutions, the customer is connecting to a remote data center that is run by a third party, where their applications are now hosted. However, that data center in the managed solution context is an extension of the customer network. It is practically theirs. It's their network. They're just extending it to a third party. Now, in the software as a service cloud, on the rightmost side of this diagram, we're seeing that the patterns of data access, the user experiences, the collaboration patterns, they do change. And these changes are quite fundamental. The users are interfacing with more than one cloud. The users are collaborating across organizational boundaries. So as a consequence, we're seeing that many enterprise legacy network investments, networks that worked for on-premise, networks that worked for connecting to remote data centers for managed solutions offerings, they do not necessarily apply or optimal for software as a service cloud computing. And finally, many enterprises are telling us that they have concerns about agility and unanticipated growth and anticipated consumption of the software as a service cloud. The first popular question that enterprises ask is, what is my bandwidth envelope for Exchange Online? Or how much connection concurrency do I need provision for OneDrive for Business? These are fairly tactical questions necessary to unblock the deployment, but the key concern is, how will your network scale when you exhibit this unanticipated growth? So hopefully, in the context of this discussion, we should be able to give you some principles that ensure future-proofness and the scalability of your connectivity strategy. Truly, to turn into the connectivity strategy from a bottleneck into the cloud enabler. All right, so let's look at the context of the enterprise connectivity strategy. We're not hearing that much angst from small and medium businesses and consumers. For them, connecting to the cloud is largely a no-brainer. The large reason for that is because in consumer and small businesses world, the connectivity to the internet that the people are often using as a starting point to connect to the cloud was dominating their bandwidth and connection concurrency needs. Small and medium businesses, they do not have a developed WAN, so for them, leveraging the ISP, a basic firewall to connect to the internet, was relatively simple. And when Office 365 or any other software as a service cloud comes along, then it blends right in. The bandwidth demands of a small and medium business is dominated by Netflix and YouTube, so adding a few users from Office 365 doesn't change much in that landscape. However, for enterprises, the landscape is drastically different. There is this big, fat stack of security and network controls that separates the inside of the enterprise from anything outside. Solutions vary from developed WAN, various acceleration technologies, NATing, DLP, security controls, firewalls, modern technologies such as secure web gateways and proxies. Transferring Office 365 experience or collaboration experience across that boundary could be very complex. And that is the main reason, the main bottleneck that we're seeing enterprises have when they onboard to Office 365. That blue box with a lot of diversity that was provisioned initially for recreational internet browsing. In addition to that, the enterprise challenge has a very distinct last mile. So if you picture the world as the cloud service network on the right, and then the enterprise network on the left, and then there is an NSP or ISP internet connectivity in the middle, and place the consumer and the enterprise user, we will observe that the topological placement of both is drastically different. The first mile, which is within their cloud service provider boundary, this is where a lot of the engineering investments that Microsoft is doing apply. But when the user is connecting to Office 365, from the consumer perspective, that distance is fairly short. You probably have your wireless modem at home and your ISP, and then you're right on the Microsoft network in most cases. For the enterprise, the last mile is long and largely hidden. Most enterprises today traverse their corporate backbone in order to reach the internet egress. And then that internet egress applies a layer of security policies which further prolongs the distance in the virtual sense of how far the user is perceived from the service. So that, in addition to the complexity of the enterprise edge connectivity to the outside world, the last mile and the hidden aspect of it is generating a lot of pain, performance problems, and availability challenges. So now once we outlined the enterprise challenge, let's try to taxonomize this and then figure out some basic principles that we're advocating you consider when you're connecting to Office 365. But before that, a little bit of a taxonomy element. We'll look at different types of clouds, and we'll look at that from the perspective that your connectivity strategy is directly related to what type of cloud you're trying to connect to. If you're looking at the type of the cloud, such as infrastructure as a service or software as a service, the nature of the destination cloud pretty much determines the type of the connectivity that you want to get. So let's look at some of the common trends on both sides of the spectrum. If we're looking at the infrastructure as a service, it is largely targeting firsthand IT professionals who built their solutions and then place them in the infrastructure as a service. The prime example here is Azure Virtual Network or Azure Compute. Users do not access it firsthand. First, IT professionals need to build up their network in the IaaS data center. They need to place their application there and then allow the users to connect. In the software as a service world, on the right side of this diagram, the users, the customers, are connecting directly and consume finished application. In the IaaS world, the customer focuses on the solutions that are specific to their organizational boundary. In the SaaS world, the users are connecting across the boundary, across the network, in order to reach those applications. Another very important element here is that in the IaaS world, the tenant is a networking-specific concept. You virtually have a data center that you're extending your network to, and that becomes part of your tenancy from the network level up. In fact, many customers in the IaaS world, they bring their own network. They bring their own solutions. They bring their IP addressing scheme. In the SaaS world, there is no your network. The network is pre-built. It's specific to the SaaS provider. It is highly distributed. It is not location specific. One of the worst questions you can ask from the networking perspective is, where is the Office 365 data center? That question by itself is rather meaningless because Office 365 has presence in large number of data centers worldwide, and you can take advantage of that presence. So don't focus on a specific point-to-point connectivity in that context. That arrives us to a very important conclusion, that for IaaS, the mindset is designing your network and customizing and extending it into the IaaS world. In the SaaS world, you need to understand how the SaaS networking is done. You need to align with these broad trends, and you need to connect and relate to it. There is no customization of the SaaS network in the strict sense. There is absolutely ways to have your networking and connectivity investments accrue to both of these worlds. Many enterprises that drive common strategy to connect to any type of cloud, to consume them all, common infrastructure investments as far as the principles, but it largely drives differentiated setup between IaaS and SaaS connectivity. So for the remainder of this talk, we're going to be focusing on the right side of this diagram. I want you to wear the SaaS hat, and we're going to look at the Office 365 as a prime example of the SaaS connectivity. Now, the power of this discussion is that most of the principles that we're going to be discussing here hopefully will accrue to all your software as a service needs, not just Microsoft's, but also third parties. So hopefully you'll find these principles relevant for even outside of Office 365. So focusing on SaaS specifically, let's look at the core trends that are happening in the industry. Trends is something that you cannot directly influence, but from the practical perspective, it's highly beneficial to align to. These are giant waves of shifts in the connectivity world that many enterprises observe as they connect to software as a service applications. The first one is that SaaS by itself changes the fundamentals of networking. The network is no longer traditional point-to-point, where you say, I have a remote data center that I want to connect, I provision a private line into that entity. In the SaaS world, the connectivity is distributed. You're connecting to the cloud, to multiple applications that are geographically dispersed. So think less point-to-point, think more full mesh. And the fuller this mesh is, the better is your user experience. Security controls. In the past, network was focused on applying security controls to all communications that were traversing the boundary. In the new world, we're seeing a trend where controls and security assurances are being pushed from the network into the application layer, into the cloud itself. That gives a unique opportunity for enterprises to refocus their security investments from being purely network-driven to a combination of the cloud and the on-premises network that connects to it. Internet becomes closer. 5 years ago, there was a common scare. If you connect to something across the internet, that must be bad. You need to stay away from that. But the reality of this is, in comparison to the conventional internet browsing, cloud service providers such as Microsoft, they invest very heavily in establishing distributed peering relationships of their network to as many ISPs and NSPs as possible. So in the practical sense, most of you who are connecting to Office 365 across the internet experience a very short internet distance, like the picture on the right. When you exit to your upstream ISP, who has peering relationship with Microsoft in the same very location where the user is situated, it will send that packet into the Microsoft network as quickly as possible. So in reality, that uncertainty of the internet from the availability and the security perspective only focuses on a very short distance, in many cases just a couple of 100 feet of fiber optics located in the carrier-neutral facility. Diversity of connectivity options. If you're evaluating different ways of connecting to the cloud, you may be overwhelmed with a different set of choices, ranging from traditional on-premise equipment all the way into managed services. Sometimes these choices are tweaked or customized for individual cloud-based applications, ranging from untrusted to trusted clouds. And then finally, the connectivity to the internet is moving to the cloud itself. We're going to touch on that later in this talk, put some emphasis points here. But if you look at all these trends, these are fundamental shifts that influence how enterprises think about the connectivity. So let's keep those trends in mind and then project some of them to Office 365. So Office 365 is not a virtual data center that is an extension of your on-premise environment. From the connectivity perspective, it is an ecosystem, a distributed ecosystem with a collection of workloads. Architecturally, it's a set of microservices that are grouped to deliver collaborative scenarios. If you think about Office 365 and the full fidelity of the user experiences, you may observe that the user is interacting with dozens of microservices, ranging from well-known ones, such as Exchange Online, SharePoint Online, Skype for Business, Teams, system services, such as Azure Active Directory, who is responsible for providing the directory and authentication plane, as well as some of their auxiliary services like content distribution networks. So all these services that are packaged to deliver the collaboration user experience. And richer collaboration drives expansion of those services. That's what explains the fact that the list of those services and the corresponding endpoints grows pretty much every month. Now, we publish for people who deal with networking, we publish definitions of Office 365 services. There is a well-known page, Office 365 URLs and IPs. People who manage networking can visit that website to download the settings, IP definitions, URLs. One of the feedback that we were getting from networking professionals is that that information is complete, but it's very complex and it changes very often, right? That feedback resulted us in looking into some of the common patterns there and realizing that out of literally hundreds of different URLs and IP subnets, there is a set of core services, such as Exchange, SharePoint, Skype for Business, that account for the bulk of the networking demands. So if your network, in addition to just permitting connectivity to Office 365, needs to optimize some of the most critical Office 365 experiences, you may want to focus your attention on these core services. Statistically, they account for about 95% bandwidth, connection concurrency, transactions per second that offers networking professionals a way to focus their optimization on the set of services that directly relate to the critical user experiences. And we're hearing customer feedback that you want more automation, more transparency in how Office 365 is related to enterprise connectivity. So we do have plans to update that resource to give you better pivots to project into the network settings that you need. Once we realize that Office 365 is a distributed system, it's worthy to talk about one of the fundamental pivots of great software as a service performance, and this is latency. Many people say that latency is the main currency in the performance world. Once you spent it, you don't actually get it back. We're going to pivot the concept of the latency from two perspectives: the distance of the path that the connection has to travel, as well as the application processing overhead that the user is experiencing through all their middle tiers that are on the way. Latency is an end-to-end concept. It has taxes on the customer on-premises environment, callouts 1 through 3 here, as well as the cloud-induced latency. If you visited the Insights of Exchange session yesterday, there was a lot of discussion about the engineering investments that we're doing inside the cloud to make sure that the user latency from their outside of the Microsoft perimeter into their location where the data is stored is greatly minimized. I think they're citing that P99 latency is approaching speed of light. So how can you make sure that these investments accrue directly into your user experience? The focus becomes 1 + 2 + 3. Is minimizing the latency between the end user and the moment when the packet is handed off to the Microsoft ecosystem. So let's take a look at another important concept which helps and plays a pivotal role in the end-to-end latency conversation. And that concept is the service front door. That concept has many names. You may have heard this term being used under the label of Azure Front Door, or Front End, or Client Access Front End, or Relay Server, or a Content Distribution Node. These are all implementations of different workloads of the same very concept. The concept of the front door that the user is connected to via a URL or a set of IP addresses to interact and get end-to-end Office 365 experience. The user does not connect directly to the data store. It always goes through a set of distributed front ends, which are workload specific. So Exchange has its own set of service front doors, Skype has its own, SharePoint has its own. The technologies vary, and for those who are interested in the details of how the front doors distribute the traffic, how they load balance between each other, there is a separate session, I think, either later today or on Thursday. But all these technology differences, they still deliver the same very concept, that the users connecting to the front door getting the optimized user experience. So don't worry about the differences in technologies. You can solve this equation with one common principle. Design your network so that the users connect as quickly with as least overhead as possible to the nearest service front door for the given workload. And because a lot of these technologies that the front doors are using, ranging from Anycast DNS, Anycast TCP, GeoDNS, and application discovery, they somehow get tied to name resolution. In order to take the best advantage of the front door proximity, we recommend that the name resolution plane is also matching the data egress plane. With those two principles, you're taking full advantage of Microsoft investment in the front door technology. In this context, once you fully realize the benefit of the front door, the cloud effectively becomes closer to you. It moves closer and closer. So let's look at this in motion. There are 3 investments that Microsoft is doing to make the cloud appear closer to you. Number 1 is their development of the Microsoft Global Network. For networking professionals, Autonomous System 8075, you can look it up at PeeringDB, one of the best peered networks in the world, both in terms of presence, the number of ISPs, and the backhaul capabilities. The distributed front door infrastructure that we just discussed, the importance of that is that it terminates user connections, optimizes connections of the back end. A lot of the TCP and SSL operations become very, very fast if the front door is close to the end user. And finally, intelligent placement of the data within the Microsoft Cloud, right? There is a steady, positive forward motion to evolve that ecosystem to move it even closer to the customer. The peering locations where Microsoft peers with many, many different ISPs. I think the latest count was 2,700. I looked last week, and this count is always evolving. 150 peering locations, 100 locations where the front door infrastructure is established, and all of that is evolving progressively towards your network, towards your customer, right? The end result and the whole goal of these investments is to make the cloud appear closer to you. So as a network designer, as the person who architects and influences on-premise network deployments, in order to take advantage of those investments, you need to focus on a couple of key principles. So let's look at how these principles play in the real deployment. So first, we'll consider a default connection flow from an enterprise with a set of branch offices and a data center with an internet egress happening through the data center. Following this red line, the connection goes through the customer network, backhauls from San Francisco into Miami data center, or in Orlando data center. We placed it here conveniently. Believe me, there are customers who build data centers in Florida, despite the hurricane seasons. And then the connection reaches the Microsoft network, which also has peering relationships here in Florida, hits the front door, and gets to the back end. The end-to-end latency envelope for this engagement is roughly about 65 milliseconds, give or take. Now, let's assume that Microsoft evolves their peering relationship and now has a presence in San Jose, which we do. San Jose is one of the main peering locations of 8075 on their West Coast. This gives an opportunity for the customer to egress locally, leverage their ISP, and short hopping into the Microsoft network right there. The second you do that, your Office 365 experience selects the local front door and approaches the experience locally. The end-to-end latency envelope for that engagement is roughly about 25 milliseconds. So that's more than 2x win immediately. Now, we also have front door infrastructure in many, many locations. And we do have front door infrastructure in California. In this case, the connection may actually enter the Microsoft network and gets terminated and serviced right from their service front door infrastructure in Silicon Valley. And then the front door will proxy that connection to the location where the data is. The latency envelope that the user perceives is 5 milliseconds. The interface with the front door, all the round trips, all the connection negotiations happen very, very fast. But that's not it. The front door infrastructure is so important for internal optimization that the intelligent data placement for some workloads, such as Exchange Online, may actually move the data within the compliance boundary, within your tenant-specified geo, closer to the front door, which further optimizes your experience. So connecting the user to the closest front door not only reduces the latency envelope between the user and the cloud, but it also empowers the cloud to make intelligent data placement decisions. Now, for security people, there is an immediate red flag. What do you mean Microsoft moves our data, right? It's not a data move across the boundaries. This is basically intelligently selecting the place where the data is already stored, but served directly to the user. So all these data reallocation permutations, they happen still exclusively within your tenant geo boundary and within the compliance boundary. This is just a micro optimization applied on top of the existing topology. Now, let's suppose that the customer believes in private connectivity. In this case, the customer wants to have private connectivity from their Orlando data center into Microsoft, and the customer may use ExpressRoute or any type of other point-to-point connection for that purpose. And looking at the different provider landscape, let's say the customer selects a provider that peers with Microsoft only in one location, in Washington, D.C. So let's see how this plays out. The private connection to Microsoft network is established from Orlando data center to Washington, D.C. But doing that influences their user traffic at global scale. So now the user connection from San Francisco office gets attracted over that private connection and goes the longer path to Orlando, to Washington, D.C., hits their suboptimal front end in this particular example, and can actually cause the data to be shifted towards the wrong direction. So the latency envelope here is roughly about 85 milliseconds. Now let's compare the different cases. 5 milliseconds in the green case and 85 milliseconds in the red case. That is a substantial difference, right? So I think if you design and optimize your network in alignment with the principles that were outlined here, you can get very tangible performance benefits. The typical question that the customers are getting is, how can I make sure that I abstract myself from all that complexity? I don't want to dig into the details of which front door technology does Exchange use today, or which technology stack is Skype for Business using. Just give me some simple principle that is future-proof, that I can optimize my network and stay assured that it's going to be valid for the years to come. Practically, that principle is very simple. Always egress Office 365 traffic locally and match the name resolution with it. Doing that ensures that your path into the Microsoft network, your front door selection stays optimal, and that ultimately drives the intelligent data placement as well. Now, the same very principle should be scaled across every satellite office, across every point of presence that you have, mapped into the Microsoft global network, which is pictured in this slide, more than 150 locations worldwide. And that principle is so important that it's probably worth restating it again. Egress locally for the optimal Office 365 experience and put it right in the middle of the Pacific Ocean, right? In fact, there have been a few independent studies. I think there is a company, GSX Technologies, I think they are presented here at the vendor stand, and they did some performance evaluations of Office 365, Exchange Online specifically, performance experiences using different egress paths. And their study yielded a stunning conclusion that every performance test they run, egressing to Microsoft network as quickly as possible, which practically means practicing local egress as closer to where the user physically is, yields the best performance results. And that statement is probably another worthy one to anchor right in the middle of Atlantic. So those are very important principles to align your network evolution to. Now let's do a quick show of hands. As you think about your existing enterprise network deployment, large number of satellite offices, data centers that you have, how many of you are currently practicing local egress with a matching DNS resolution? How many of you are in the green bucket? All right, see a few hands. Well, how many of you are practicing local egress but are not aware of their DNS level optimization, which means that you're likely in bucket number 2? A little bit more people, all right? Well, how many of you are practicing remote egress to Office 365, someplace away from the end user location? Well, even more people, right? And then finally, how many of you are having religion about dedicated or private connectivity to a distributed software as a service cloud that optimizes the presence as closer to the user as possible? How many of you are doing dedicated or private connectivity? Well, a few hands, right? Well, I reserved the 5th bucket here. The 5th bucket is you actually don't know, but it's a good thing. I encourage you to have discussions with your networking team and confirm which one of these lines is your deployment getting aligned with. And from the practical perspective, we strongly encourage people to exercise more and more patterns around flow number 1, which is local egress and connecting to the local closest front door that Office 365 has in the location of the user. All right, let's shift gears a little bit. Let's talk about trust. On one of these sessions, I think they asked their attendees to take their phones, unlock it, and then pass it for the duration of the session to your neighbor. We're not talking about that type of trust, right? We're talking about the network connectivity trust, the trust in their destination that you're connecting to, and the security controls that you're applying at the perimeter. So let's do a little bit of algebra, right? Let's draw a graph. On the horizontal axis, there is a degree of trust in the network destination, and it's never infinite, but there is probably some buckets along the way. And on the vertical axis, there is overhead, right? something that you need to spend on the network in terms of complexity, cost, compensating controls, inspection depth, and potentially latency. The dependency graph looks largely like that, right? If you are connecting to a destination that you don't trust, such as generic internet that serves you rogue code, that could impact your users immediately, you probably are incented to have a lot of compensating controls along the way. Your complexity goes up, your costs go up, your latency go up. But if the volumes of traffic are okay, if the experience of recreational internet browsing is not demanding, that's probably okay, right? That's manageable. However, if you're relating to a trusted application, the application that has verifiable assurances and outcomes, you can afford to have fairly moderate, optimized networking middleware that connects you to that destination. And there is a set of technologies that nicely fit on that curve, ranging from the right on conventional firewalls at layer 4, maybe DNS-based firewalls, rather low overhead, all the way into proxy type of engagement. And the extreme case is content inspection, content manipulation, scrubbing, tokenizing, all this high overhead stuff that you need to relate to a completely untrusted destination. Well, the way we encourage our customers to look at that graph is, where do you place Office 365 here, right? And what is more importantly, as you go through the evaluating of Office 365 features, which part of that curve does Office 365 slide in? The truth of the matter is we're investing a lot in Office 365 security controls. I placed the list here in very, very small fonts. There is a URL here on this website that shows you different aspects of Office 365 feature set, ranging from auditing, security, compliance controls, going into specific tenant restriction, conditional access features. Our hope is that that enables you to have focused discussion with security teams around leveraging more Office 365 experiences and shifting that equation to the right. So that Office 365 is in the green zone of that diagram, lower overhead from the networking perspective, faster performance, lesser cost on the networking infrastructure in between. So the guidance here is evaluate Office 365 features, focus on outcomes, not the implementation, consider the scale vector, doing security at 10 gigs per second, doing content inspection and manipulation at that scale is difficult. There are very, very few solutions that can do this, and most of them are expensive and very fragile. Look at differentiating Office 365 traffic if is necessary. Most people say outbound is no problem, but inbound, when the cloud establishes connection to me, I need to do something different. So those are very valid pivots. And then the ultimate outcome that you want to drive for is have duplicate security that already exists in Office 365, the features that you can natively leverage in Office to achieve the outcomes that you want. You reduce the burden of network to achieve the same outcomes and optimize for the end user experience. All right, so let's take a look at another pivot. Another theme, another trend. Internet is also moving to the cloud. The connectivity itself, that security stack that you used to have on premises, that was complex, quite expensive. There are ways of moving it to the managed service. So this is driven by the industry trends. There are a lot of solutions, a lot of ISVs out there. And the basic motion there is a third-party cloud that inserts themselves in the middle from your on-premises user all the way to the internet destination. In this case, Office 365 traffic may also be affected, impacted, or unblocked by this engagement. The security stack is now provided by the solution in the cloud. There may be some additional functionality from content inspection to proxying to auditing controls that is added on top of that. And the internet traffic is being funneled right through it. Lots of benefits that the customers can realize to manage your untrusted internet destinations with this amount of scrutiny. But the downside is that from the Office 365 perspective, if that traffic is attracted in and it doesn't necessarily get handled in the most optimal manner, there could be impact. So what can you do to make sure that if you're planning to use some of these managed solutions, cloud-based security offerings, that Office 365 experience is not impacted? The outcome is actually quite simple. look at Office 365 principles, local egress, trusted connections, least number of overhead, to evaluate these third-party offerings, and look at the physics level. Ask, where is the peering locations? How many interconnects does that solution has with Microsoft Network? And again, the objective is to build the full mesh graph, local egress through the same location as the user, going to the cloud service provider in the same area that hands it off to Microsoft, again, in the same metro. Build the full mesh graph and have Office 365 experience optimized on that plane as well. If in doubt, Microsoft recommendation is bypass this third-party security stack. Make sure that the Office 365 experience is not impacted before subjecting the users to this man in the middle. Bit word about the SD-WAN. SD-WAN is the new approach. It's bringing software intelligence into the networking world, empowering the network to make decisions at the routing level with application, business, and flow awareness. This is a very powerful concept because from the Office 365 perspective, SD-WAN technologies empower the network to fulfill that principle of local egress in next to real time. So let's take a look at how this could be done. In this topology, the customer deployed an SD-WAN solution at their satellite offices and at the data center. They leverage multiple ISPs, maybe the LTE network, as their redundant connectivity from their satellite office. And the SD-WAN solution, in real time, looks at the traffic patterns, determines it to be Office 365, and fulfills the principle of the local egress, sending it to the closest front end, to the closest entry point into the Microsoft network. Should there be a failure, the software-defined networking, software-defined WAN detects the failure, it has the application awareness, and then adjusts the path into the next best relationship for that connection. And at the same time, keeping the internet engagement, the internet flows, handled according to your business policies, maybe routing it through your internal WAN to a data center where additional scrutiny, scrubbing, content inspection is applied, maybe sending it to one of these cloud service providers that perform secure web gateway functions. So we are actually very positive about the SD-WAN technology stack because it gives the application awareness. Many solutions out there detect Office 365 traffic. They automated their definitions that Microsoft provides, and it can help you to dynamically determine Office 365 flows and treat them in accordance to your business policy separate from the internet. The last slide, the talk wouldn't be complete if we didn't talk about the availability, right? Networking has profound impact on the availability envelope. I posted some stats here. I think in the previous talks, people reflected on the uptime that Office 365 and Exchange Online specifically was able to accomplish. We're hyper-focused on the availability, but at the same time, it doesn't always translate into the uptime for the end users. And connectivity between the end user and the cloud is often the key. One basic principle here is that no individual SLA or a component uptime would compensate for a single point of failure. So the key message is, as you design your network, avoid daisy chaining of solutions where an SLA-backed up component is, in essence, representing the single point of failure on the end-to-end user experience. So in this diagram, the diagram on the left, you can see a solution that has leveraged the managed networking connectivity into a managed security stack, and then the private connection into the Office 365. But the problem with that, it's single-legged, right? It's a serial connection of these components, and each of them may have 4 nines of availability, but as you daisy chain it together, the resultant uptime is 3 nines 5. On the other hand, if you take the approach on the right, which is geo-redundant connectivity, you can have a 2 nines solutions in the middle, yet you will still get 4 nines mathematically end-to-end because the solution is configured in the active geo-redundant fashion. So I think that is a very important pivot, that connectivity has a profound impact on the way that the users are perceiving the service, not just from the performance perspective, from the complexity and security trust perspective, but also from the availability perspective. All right, I'm going to wrap up my part of the talk to summarize the principles that we targeted. You will see these principles repeated in all the other connectivity talks. Identify Office 365 traffic and treat it according to a business policy separate from the generic internet egress. Keep the egress local with a matching name resolution. We talked about the profound impact that it can have if you follow that principle from the performance perspective. If you're using any type of managed security offerings, be extremely careful about hairpinning effects. Ask the physics questions about peering, about the interconnects, about location, and really project it to all the user locations that you have. And then finally, assess the vast majority of the security features that Office 365 provides. See if it can accomplish your business goals, that can ease the burden on the networking layer to yield better Office 365 experience. And if you find duplication, consider the bypassing for Office 365 traffic while keeping the rest of the internet traffic in place. With that in mind, I'll pass it to Jeff, and we'll talk about a few case studies from real customer deployments that realize those principles.
We're actually, am I on? We're actually already a minute over, so I'm going to briefly summarize mine and skip to the end. But essentially, one of my roles within Office 365 is managing customer escalations in this space. And so myself and a number of people on my team deal quite a bit with direct escalations that come in around connectivity issues. And I'm going to skip through these rather complex build slides and just pull up the key points that I want to make here. Because there's essentially 3 buckets of case studies that we're describing here. One of the common areas, the common themes that we typically see is that due to the lack of trust today of Office 365 connectivity, Kostya showed the beautiful chart that we hope you take home and digest. Because of that lack of trust today, many of our customers are sending their Office 365 traffic through existing proxy infrastructure and treating it as essentially untrusted traffic. By avoiding that, you avoid quite a few potential congestion issues, quite a few potential issues with additional latency that's imposed by those types of devices, and you end up with a much better experience. So being able to identify that traffic and move it away from that infrastructure is very critical. This is also another extremely complex build slide with a large worldwide customer. The key here, I'm going to skip through all the beautiful diagrams of the network path. The key points, we'll get there eventually. The key points around this particular example, we really want to avoid backhauling Office 365 traffic on a corporate WAN, and wherever possible, aim for local egress. That's extremely critical to be able to take advantage of the engineering investments that Kostya talked about, that we talked about yesterday in the Exchange Online internal session, and that we'll be talking about in every other networking session here focused on Office 365. ExpressRoute can come into play, and in this particular customer case study, I was going to talk through how it specifically resolved a congestion issue in one particular location for this customer and helped to relieve some issues there. And while it may have done that tactically specific to those congestion issues, it didn't actually resolve the latency issues that were also a result of hairpinning the traffic through one particular egress location. Understanding that Office 365 has global presence and that getting to those service front doors globally is, it should be absolutely the focus when you think about architecting your connectivity to our cloud. And the last one, Kostya mentioned the concept of having additional third-party providers of things like secure web gateways or CASB devices that may be in the path for internet egress for a corporation, for a large enterprise. Understanding the impact that those can have on Office 365 traffic is quite critical, and making sure that you're actually partnering with a vendor of those solutions that peers well with Microsoft and that has a good way to identify our traffic is also extremely critical to having a good experience with our products. So the key points here in this example are that some of these solutions may today not be well aligned to our strategy. We're here trying to educate all of you as well as our partners in this space around our strategy so that we can all have a better experience with Office 365 moving forward. It's really important to understand the peering strategy of these partners and understand whether they have presence in the areas where you're trying to connect with them and where they would connect with us to egress their traffic onto our network, as well as to understand whether they have the ability to identify Office 365 traffic, trust it in a different way, and avoid doing things like affecting all of that traffic, potentially manipulating it in various ways, trying to implement security features that may be duplicated within Office 365 that you're already paying for and can take advantage of without actually having an impact on the performance of the service. So with that, we are done for today. Thank you very much. We certainly would love to get feedback from you. Please give us feedback via the app. We actually don't have the barcode slide, so we'll leave this as the last slide up here. But you can certainly give us feedback in the app very easily. So thank you.
Thank you.